Today we're going to take what we know about inequalities and begin to solve compound inequalities. Compound inequalities deal a lot with true and false statements, so we'll begin by filling out this truth table and talking about how compound statements work. So this particular truth table is an AND truth table, and we want to know when P and Q is true, when P and Q is true, what has to happen? So we begin looking at these statements. A dog is a mammal. Is that true? Yes, that's true. Red is a color. That's also true. P and Q. Are both P and Q true? They are. So this is true. A dog is a mammal. True. Red is not a color. That is false. Red is definitely a color. So are P and Q true? They are not both true, so this is false. A dog is a fish. That's false. Red is a color. That's true. Are they both true? They are not. This is a false statement. A dog is a fish. That's obviously false again. Red is not a color. That's also false again. So are they both true? No, they're both false. So P and Q is true when both P and Q are true. So the key here is both. You can see in some of these tables, one's true, but because the other one's not, the entire statement is not true. So if you have an AND statement, they both have to be true. Now we have an OR statement. 1 is an odd number. That's true. 2 is an even number. Also true. This here, this is a typo. This should say OR. P or Q. Are either one of these true? Yes. In fact, they both are, so we'll call it true. 1 is an odd number. True. 2 is an odd number. False. Are either of them true? Yes. 1 is an odd number is true. P is true. 1 is an even number. False. 2 is an even number. True. So this can be true because we have one of them that's true. 1 is an even number. False. 2 is an odd number. False. So this is false. So if you think about the difference between these two, you have more options to be true during an OR statement. So P or OR is true when either P or Q is true. So remember, in our last slide it was both. In this slide it is either. So let's jump into an inequality. This is an old example. This is part 1 of an old example. We know how to do these. This is a one-step inequality. In order to solve it, we just divide by 2, and we get x is less than or equal to 6. So down here we're going to type that in, less than or equal to 6. Done. We know how to do that. We totally know how to do that. We do it really well. Let's do the second part of this, and I'll show you how they combine. But keep this in your mind. Keep this in your notes. Here we have negative 14 is less than or equal to x. So we're going to go ahead and solve this. 2x. So divide by 2. And negative 7 is less than or equal to x. So if we put x first, which one's greater? Which one is this alligator mouth eating? It's eating the x. We want to make sure that it's still eating the x. So negative 7 is less than or equal to x. So x must be bigger or equal to, greater than or equal to negative 7. And we'll go ahead and type that in. Greater than or equal to negative 7. So we have these two examples where we have negative 14 is less than or equal to 2x. And then we had 2x was less than or equal to 12. So what we're going to do here in our next step is we're going to combine them. So you can see right here was our first inequality, and this was our second inequality that we solved. Because this is in the middle, we know this is an AND statement. So negative 14 is less than or equal to 2x and less than or equal to 12. We'll show you what an OR statement looks like next. But this is definitely an AND statement. So they both, remember with an AND statement, they both have to be true. They both have to be true. So we're going to go and solve exactly the same way we did in the past. Let me get rid of these lines. And we're going to say, all right, well, if I want to solve this, I divide by 2. Divide by 2. Notice I've done it to each term in the inequality. And I end up with -7 is less than or equal to x is less than or equal to 6. That's exactly how I'm going to type it in. So this is new. We have to input the x this time because it's a compound and inequality. So -7 is less than or equal to x is less than or equal to 6. And notice, it goes here from smallest, -7, to largest, 6. That's the way that our inequality should be written. We shouldn't have the signs facing the other direction. It should always be smallest number on the left-hand side to the largest number on the right-hand side. Here's an OR statement. So we have x divided by 5 must be less than or equal to 0. We can go ahead and solve this one. So we end up with multiplying by 5 on both sides. And 5 times 0 is 0, so x must be less than 0. And then over here we'll go ahead and we'll add 2. So x must be greater than or equal to 8. And we'll go ahead and we'll put these in our blanks down here. So we'll go ahead and enter into our first blank, x is greater than or equal to 8. And in our second blank, we'll enter x is less than 0. Now if you're wondering which blank it has to go in, it doesn't matter. I could have put x is less than 0 first. So you can put either one in either blank and it'll still be right. Just make sure that the x comes first and you must include the x. So that's different. You need to include the x on these. Here's our next example. X -2 is less than x plus 1 is less than 10. So this is an AND statement, which means that both must be true. And both. I subtract 1. And I get -3 is less than x is less than 9. And I will go ahead and type that in. And we're ready for the next one. Here I have an AND statement again. AND means both must be true. I'll begin by adding 2. This is a multi-step, but you guys can do multi-step. And I have 15 is less than 3x is less than 18. And then I divide by 3. Remember, each term is divided by 3. And now I have 5 is less than x is less than 6. And I can go ahead and type that in. Here's our next one. It's also an AND statement. Subtract 6 from both sides. I'm just doing my inverse operations. And I end up with -30 is less than 5x is less than 30, positive 30. I divide each by 5. And I end up with -6 is less than x is less than 6. Notice as I write these in, it's always smallest to largest. Here's our next one. I'm going to go ahead and multiply by 10. This is also an AND inequality. You're seeing lots of AND inequalities. 10 divided by 10 is 1, which is an identity when you're multiplying. And I have -10 is less than x is less than 10. And I can type that in. Here we have an OR inequality. I will add 6. And this is now x is greater than or equal to 7. I can type that in. And then I go ahead and complete this other one by subtracting 6. And I have x is less than or equal to 6. And again, those can go in either blank. Here's another OR statement. We are missing some value here, so I'm going to go ahead and skip this example and get to an example where we have all the values. Here we go. I'm going to go ahead and add 2, and now I have, I'll write it down here, negative 3x is less than, this is a plus 2, 15, divide by negative 3. This is the first time we've seen this in this set of examples. When you divide by a negative, or when you multiply by a negative, your inequality sign switches directions. I can go ahead and type that in. X is greater than negative 5. And my second inequality, there we are, negative 6. And I have 4x is less than negative 24. I divide by 4, and I get x is less than negative 6. I'm done with this example. On to example 10. This is an AND statement. I add 2, and I end up with negative 5 is less than x is less than 1. Again, smallest first. And I'm done with this example. Our example 11, subtract 5. And now I have, I'll write it down here, 5x is less than negative 20. Divide by 5. And x is less than negative 4. Okay, just looking for the mouse. There we go. I'm going to add 7. And I have 4x is greater than 0. I divide by 4. And x is greater than 0. Here's our last example. This is an AND statement. I add 1 to both sides, and I have negative 42 is less than 7x is less than negative 14. Divide each term by 7, and I have negative 6 is less than x is less than negative 2. And again, I write it in with the smallest to the largest. And we're done. You can see this is just one small extension from what you were doing previously by adding a compound inequality with another portion on the other side. So you have some x variable in the middle, or you have an OR statement that you need to solve. Good luck.